dot g has to be less than or equal to their norms multiplied together. And that makes sense once you learn to prove that the dot product is just the norms multiplied together times cosine theta, which cannot ever be greater than 1. So here, it's not quite the same as this, because there's no such thing as an angle between functions. But the Cauchy-Schwarz inequality still holds. So what is the norm here? Well, this is just going to be the square root of f dot f and the square root of g dot g. That's what the norm is defined as. And that's got to be greater than or equal to their product. If you square both sides, like we need to do here, you get that this is less than f dot f g dot g. Now, why did we need to square both sides? Well, if we multiply these two together, we'll get that this multiplied by this. We're going to abbreviate this as f and this is g because it's too clunky to write right now. This is just going to be f dot f g dot g, which is greater than or equal to f dot g squared by this logic. So we now have this relation, but can we go any deeper? This still isn't what we want yet. Well, in fact, we can. What exactly is inside f dot g squared? Well, recall that f dot g is some complex number